This reaction, this usually happens pretty slowly, okay? You wouldn't normally even see the bubbles, but we're going to do something to speed the reaction up. And what we're going to do is we're going to add what's called a catalyst. A catalyst is something that speeds up a chemical reaction. An inhibitor is something that slows down a chemical reaction. And the really cool thing about catalysts and inhibitors is that they're not actually used up in the experiment. So if you look at the equation here, H2O2, I put yeast, which is the catalyst, on the arrow, not as part of the equation, because when you finish the reaction, you have exactly the same amount of yeast after the reaction as you did before. Okay, the yeast is just there, kind of like if you go to the playground and you go on a swing, somebody can push you on the swing and it'll make you go higher and faster, or you can just swing on your own and it's still fun. Okay, so the catalyst is kind of like the person who can push you on the swing. They can make it go faster, but the same thing would happen eventually, even without, okay? So I'm putting a little bit of water in each of these flasks, in each of these three flasks, because I need to make the yeast a liquid. So the yeast is a powder, and I'm going to put 30 milliliters of water in 1 teaspoon of yeast in each flask. So I am going to need 2 volunteers. Okay, James and Emma. Come on. You guys are both going to need goggles.
Mr. L is a good photographer.
You guys are going to move around to this side, okay?
He went to college for it.
I hate these just so much messier than these to the bottom. Okay? So we're going to do a teaspoon of yeast in each of these flasks. Okay? And then we're going to add a little bit of dish soap. And you don't really need the dish soap. I've done it without the dish soap too sometimes. But the dish soap just lets you see the reaction a little bit better, because the dish soap, when soap bubbles up and foams up, it foams up because of the oxygen that you're producing when you're rubbing your hands together. So the dish soap just lets you see the reaction a little bit better. Okay, I'm going to need you guys to take each big flask and just swirl it around a little bit so the yeast mixes up with the water, okay? It's yeast like you use in bread, yeah? Okay. And like I said, I'm going to do a squirt of dish soap in each. Squirt of dish soap. Squirt of dish soap, okay? And just to make it fun, I'm also going to put a squirt, okay, you guys can stop mixing now, a drop of food coloring in each of the flasks as well. Okay, so you can put it back down on the table. And just do me a favor, put the sponges in the sink for me. Okay. Okay, so here we go.
Turning green.
Because I put a green food coloring in that one.
Turn red.
Red food coloring in this one. Yellow food coloring in this one. Okay? So now I have hydrogen peroxide in 3 different strengths. Okay? This one is 3%, like you'd buy at the pharmacy. Okay? You might use it, people used to put it on cuts. I don't think they really do that much anymore. Sometimes it's in toothpaste, or if you have like mouth surgery or something, they might tell you to rinse out with hydrogen peroxide. Okay? So this is 3% regular strength, okay? I'm gonna give that one to Emma. This one, shh, guys, this one is 12%. You can buy this one at the hair salon. If I dipped my hair in this one and left it in for a while, my hair would look like Luca's. Okay.
I'm blonde.
Okay.
It would look like Luca's.
Yeah. And this one is 35%. So this one's 3 times as strong as,
What color hair would it be?
I don't even know.
Would you look like Ryan Lochte? How like his hair got all white? Turn into
Okay. So guys, so we're gonna pour these in at the same time, okay? I'm gonna say 1, 2, 3, go. When I say go, that's when you're gonna pour, and you're gonna pour fast, okay? Everyone needs to watch, so we're only doing this once, okay? Did you fill out on your sheets yet any of the information? No. What were the 3 concentrations of hydrogen peroxide? Emma, do you remember what yours is?
3.
3%. Do you remember what yours is? 12 and mine is 35.
So rate all the percents.
What does the first question say?
What are the concentrations?
Yeah.
35. What if you get 100%?
That would be crazy. Okay, you ready? You guys in the back, if you want to move up so you can be closer and see, you can do that, but not too close, okay? You can come up if you want to come over here, maybe. Julia, over on the side here. You guys are good here. These are tables. I keep coming. You guys want to come up? Get over here.
3, 12, and 35.
Okay, ready? Can everybody see Ethan? Do you need to move? You can just sit there if you want. Okay, ready? I don't think Ethan can see.
Me? I can see.
Where are you? Okay, ready? 1, 2, 3, go.
Oh my god!
No, never mind.
Bubble! It's foamy. That's
Oh, I'm so sad. That's so cool. I'm just so sad.
It's not sad, Emma. It's just a little slower than the other 2. So which one went the fastest?
The green one.
The green one. What was the concentration of
35.
35. The pink one went next fast. And what was the concentration?
Has the most.
12.
3.
And then the yellow one was 3%. Now, this is the deal. Usually, I let people touch it, but somebody had an allergic reaction this morning, so I'm not going to let anybody touch it except for me, because I know I'm not allergic to it. This is really just dish soap now, right? When the reaction happened, all that should be coming out of here is oxygen, which is mixing with the dish soap
It's like a bubble.
to make, it's not a bubble, it's really like shaving cream. It feels a lot like shaving cream. And I want you to touch these 2 flasks, just the outside, not the foam.
Whoa, they're warm.
Okay, Emma, touch it.
They're
So it's really warm,
They are.
okay? So what kind of reaction is it?
It is a chemical.
Exothermic reaction, okay? So really, all this is this is the foam from soap, oxygen bubbles, and dish soap that made this beautiful, nice, like shaving cream almost foam. There's still yeast in the flask because the yeast sped the reaction up, but it didn't get used.
Wait, is that
Okay. And the hydrogen peroxide should be all gone when the reaction's done. Okay? Thank you guys.
Well, where do you play more about stuff like that?